All right. Hey guys, thank you for giving your exit ticket a shot. Trying something a little bit different today, and then I'm going to film a video explanation for maybe a couple things you got tripped up on the exit ticket. And that's starting with number one. So number one was just reminding you what an auxiliary set is. Remember, an auxiliary set is just a helper line or a helper, really just lines basically. Auxiliary lines are really just in your books, but something that helps you complete a proof. And so one thing that we'll prove in chapter 4 is this, that when you have a parallelogram, and a parallelogram is going to get defined for you, it'll get defined as a quadrilateral with both pairs of opposite sides that are parallel. Okay, so we'll start with that. EFGH is a parallelogram. When you have a parallelogram, the opposite sides would have to be congruent to one another. Okay, so this is a parallelogram, is this, right? There, and there, and there, right? They're parallel to one another. The thing you're going to try to prove, and this will be the very first theorem in chapter 4, try to prove that the opposite sides are also would have to be congruent to one another. As a consequence of this would have to follow. So put a question mark there, put a question mark there, put a question mark here, and a question mark here. Okay, so to prove this one, when we're going to do this, it'll require introducing an auxiliary set. So step one of this proof is actually saying it's a parallelogram, right? If we have a parallelogram, right? We got a parallelogram, right here. And right, that would mean that the opposite sides are parallel to one another. Right? That'll come step 3. You could have done so in step 2. But anyways, the way you actually prove this theorem, right? We're trying to get this congruent to that and trying to get this congruent to that. The way you're going to prove this theorem is through triangles. We need to introduce triangles here. So step 2 of this says draw segment EG. EG is a diagonal of the quadrilateral. So I'm going to draw EG. I'm going to draw it from here. I'm going to maybe draw it using this line tool here, all the way up to here. Draw EG. And I introduced the diagram. So look here, we have one triangle up here, another triangle down there. We can prove that those two triangles are congruent. That's the reason why we're doing this. The reason why we wanted to introduce that line segment right there. Okay, so when you introduce a line segment to a proof, you're saying, I know that this shape exists out there in the world. It's just not being shown to me in the actual diagram, but I can create a line. Why can I create a line? Well, there's a reason, and that is through 2 points, right? Through E and G, right? Through 2 points, exactly one line can be drawn. Okay, so that is going to be your answer to this first part here, right? So through 2 points, exactly one line gets drawn. If you're adding a line segment to a diagram, that's what you say, right? Just if you're just connecting 2 points, you're saying through 2 points, exactly one line can be drawn. That's a postulate from chapter 1, an assumption here, that if we have 2 points, we can connect them with a line. Let's just agree that that's a thing we can do, and then we can do it if we need to prove things here. Okay, so then if you're curious about the proof, you can read more about it. You don't have to. I'm just showing you that it's going to get used in chapter 4 because now that you have triangles, you have some parallel lines. You can say that alternate interior angles here. Look, this angle HGE would have to be congruent to angle GEF because they're alternate interior angles cut by parallel lines in a transversal. So they're congruent to one another. And then same thing too, that these alternate interior angles, because we have EH and GF, line GF are parallel to one another, that these two angles here are going to be alternate interior angles and also congruent here. And finally, the reflexive property, right? Step 5 is that this EG was congruent to itself when we introduced it here. So here we have ASA. That's going to make the triangles congruent to one another, and then through CPCTC. That's how we get the opposite sides, HG and EF congruent, and HE and GF congruent to one another. Yes, that's an F, not an E. Okay, so that's it, right? So if you didn't get that there, please update your answer to the exit ticket is through 2 points, exactly one line can be drawn. Okay, so that's sort of probably the easiest auxiliary set to remember. Okay, so that's what you have to remember, that when you have 2 points and you need to connect them together in a diagram, or you want to connect them together, because a lot of times they're going to write proofs for you in the book. When we get to new theorems, you'll actually see the proof and you got to be able to read it. If they're introducing a line segment, they're going to justify that by saying through 2 points, through any 2 points, exactly one line can be drawn. Okay, next one up here, I'm not going to go over this next one here for you to do because, guys, this is directly in the lesson video. So if you didn't get this one, I got a question. Did you actually watch the lesson video? Because this was the important part to put in your notes. I probably said 3 times in the video, I'm hoping at least, that this chart's got to be in your notes, right? Got to be in your notes. You got to write auxiliary sets right above it, because when you want to add stuff like this to diagrams, to help yourself in a proof. Remember, auxiliary just means a helper item that exists outside of something, right? That's an auxiliary item, something that helps something else. And it's apart from me, but it helps me. It's an auxiliary, something auxiliary to my life. Anyways, an auxiliary set is something that helps you on a proof. You want to get helped on proofs, right? So you gotta keep pushing forward and keep learning all the tricks in order to improve these facts this year. So this should be in your notes, right? Should be in your notes. I'm not going to go over it at all, but the idea is here, we did this first one here, right? If you're introducing a line segment connecting 2 points on a diagram, right, you want to introduce that. Your statement, you would say, right, we just did that in the last slide. We said segment, right, draw EG, right, draw segments EG. Here it says draw segments XO. You don't need the segment on there because this means segment, right, segment XO. Reason is, when adding a line segment to a diagram, the reason I know I can add this line, the postulate is through any 2 points, exactly one line can be drawn. Okay, that is our answer that goes here. Okay, so the answer is, I shared this with you in the video, right? It's here, but you got to know, right? You got to watch the video, take notes, try to learn this stuff, or at least try to get it in your notes and try to, like, we'll practice this. It'll come up on proofs. You don't learn everything perfectly right away, but you got to know it's in the video. You got to know how to complete this exit ticket. Okay. Second one here, when adding an angle bisector of an angle to a diagram, the reason would be, well, if I have an angle, right, what would justify that I would know I could drop in an angle bisector, okay? Well, any angle, what you're doing there, introducing an angle bisector, is that if you have an angle, you're allowed to bisect it because an angle is measured by a certain measurement between 0 and 180 degrees, okay? That's the protractor postulate, okay? The protractor postulate tells us that any angle measurement is somewhere between 0 and up to 180, including 180, but not including 0. So by the protractor postulate, because we assign a number to it in terms of degrees between 0 and 180, because we assign a number to it, the protractor postulate says, because it has a number, you can divide that number by 2, because any number between 0 and 180, any real number, it's the way that numbers work. You can divide any number by 2, okay? If you divide it by 2, you've found the angles you need to create to draw in an angle bisector. So it's kind of weird, it's kind of clunky, but the reason why, if we wanted to introduce an angle bisector, we would say, draw the bisector of this angle and maybe give it a name, like name the angle bisector. But the reason why we're able to do that is, right, the reason we could justify that every angle has an angle bisector is the protractor postulate. So that's a little confusing. The protractor postulate was a postulate that came up in section 1.3, and it's hard to read exactly and figure out what the point of it is. But really the point of the protractor postulate is that it's any angle measures between 0 and 180, up to 180, including 180. And therefore, right, if we divide that by 2, right, protractor postulate tells it has a measurement. Logic, right, like number systems, like knowing that anything between 0 and 180 can be divided by 2, means we can draw an angle bisector. So the main reason why we know we can introduce an angle bisector, the one and only angle bisector, is by the protractor postulate, okay? Would be the protractor postulate. Okay, so what I'm doing here, checking your answers on this exit ticket right here, is that I'm just checking that you watched the lesson video, right? All the answers are there. You should be able to fill these in pretty easily, okay? So I'm not gonna give you the answers to the rest, but you should watch the lesson, right? Watch the lesson, and then you won't feel behind. Okay, number 3 here, solve for x on both problems. Okay, so check this one out here. So people are having some trouble with this one here. And I wasn't anticipating quite as much trouble because this comes really early in the problem set. These are not super hard problems, I would say. You should be able to think through them, I guess. We're looking at a triangle right here. So we can actually figure out like information about how large these sides are here. First of all, I know, like, you gotta think here. Remember, what did this section have to do with? It had to do with isosceles triangles, right? Had to do with isosceles triangles, right? That was the name of the section. Whenever you're just like sit down to look at problems, you should just maybe relook at what the name of the section is and realize that the questions are going to have to do with what the topic of the section is, which is the isosceles triangle theorem. So number 2, we don't know if it's an isosceles triangle yet, right? Because remember, an isosceles triangle is a triangle with at least 2 congruent sides, at least 2 congruent sides. So these are both isosceles triangles. That's an isosceles triangle. This is an isosceles triangle. This one, we could prove is an isosceles triangle, okay? So you're given that you have a couple angles of a triangle congruent. And when 2 angles of a triangle are congruent to one another, We can prove it's isosceles because we can use the converse ITT, right? Converse ITT is the one where you start with the angles, and that tells you the sides are congruent. So if we have two angles in a triangle that are congruent to one another, then the sides opposite those congruent angles will also be congruent to one another here, okay? So simply what you need to do to solve this problem is that we know that this length, if this length were 18, okay, this length were 18 right here, then this length here has to equal 18 because it's an isosceles triangle. The ITT converse tells us that these two angles are congruent. The sides opposite will also be congruent, okay? So we are given that this length here and this length here is equal to 18 because it's 18 here. We know it's isosceles, it's 18 there. But we're also given an expression for this other side here. We're given what this 18 represents in terms of x, some unknown variable. And you need to solve for that quantity, solve for that variable. Okay, so very simply what you need to do in this problem here is this. You need to check it out here. You need to do this. You need to do 4x minus 6 is another way we're writing 18 here, okay? Because they want you to practice your algebra solving skills. That's why I want you to do this. I want you to keep developing using diagrams and seeing things in diagrams, seeing things geometrically like we're working on here, but also get that practice from algebra. So this is an algebra problem and a geometry problem together, okay? So now we got to solve for it here. So we got to isolate x. We got to figure out what x represents here. Remember, we're taking away 6 from x here, so let's give that 6 back, okay? So the opposite of subtraction is addition. We're going to add 6 to both sides, and we're going to get 4x equal to 24. And finally, what we're going to do is we're going to divide both of these by 4 because 4 times x would bring us to 24. So x has got to be 6, right? But anyways, we divide both sides by 4. Opposite of multiplication is division. So we're dividing 24 by 4. X is going to equal 6. So I got x equals 6 for this one right here, okay? This one right here, number 3, is going to be very similar to this one, maybe a little bit trickier here. We got x equals 6, okay? So you're going to put your answer down here. X equals 6. You can just put the 6 in there. You're good to go. Number 3 is a little bit different here. So this is going to develop some skills you're going to have to use on the asynchronous problem set today. But you're given this is a 98-degree angle right here, okay? This is a triangle here. This is also a triangle here. What do we notice about these sides? Okay, we're given that side congruent to that side. Sure, it's isosceles. But we're also given that this side is congruent to that side. And this side is congruent to that side. So do you think these two triangles are congruent? Why are they congruent? Okay? They're congruent by SSS. Look at this. S, side, side. Those two sides correspond. Side, side. Those two sides correspond and they're congruent. And finally, side, side, right? They share a side. So by the reflexive property, this side is congruent to itself. So these two triangles are congruent to one another, okay? So now we got to say here, well, we have 98 degrees. We got to get to x degrees here. The x degrees is one of the base angle measurements here. It's not the vertex angle, okay? So the vertex angle is 98 degrees. That means that by CPCTC, right, if this were 98 degrees, this would also be 98 degrees because corresponding parts, and these are definitely corresponding parts. Those angles are in the same position in two congruent triangles. Corresponding parts of congruent triangles are congruent to one another. So those are 98 degrees right here, okay? If this is 98 degrees, that's going to help you get the x degrees because what we know from the isosceles triangle theorem is that if we have two sides of a triangle that are congruent to one another, then the angles opposite those two sides are going to be congruent. That's the ITT. That's the biggest thing. If you don't get that yet in this theorem, you got to come meet with me. You got to come meet with a tutor. You got to sit down and really get to the bottom of this thing here, okay? So this angle we know is going to be congruent to this angle, okay? So that means that this is also going to be x degrees, okay? X degrees right here. So at this point, I think you probably know enough to set up an equation right now, okay? So check it out. There are some ways you can do this, but I'm going to do it like this, right? X plus x. What are we going to know about x plus x? What does it have to be? Well, if we added 98 to it, what's it going to equal? Guys, what is the sum of the angle measurements in any triangle, right? In any triangle. It's 180, right? It's 180, okay? So this is, right, this angle measurement here is going to be what's left off of 180 after we subtract the vertex angle and we divide by 2 because these are just the same here, okay? So this is 180 minus this equals 2x and then divide by 2. We're going to get x here. So anyways, not to overcomplicate things here, I'd set up a structured equation like this. Angle plus angle plus angle equals 180. And right, we know that these two angles equal each other, so we're going to let them both represent x degrees. So now let's combine like terms. We want to make this 2x, because x plus x is 2x. I'm going to subtract 98. I'm just going to do that in my head. I'm not going to show the work there. I'm going to subtract that from 180, and I'm going to get 82 degrees. And finally, last step, divide both sides by 2, and I'm going to get 41 for my answer right here. Boom, and we're good to go. I'm going to go ahead and enter it in. 41 is my answer. All right, and there you have it. So it was important that I went over these problems here because you're going to have, notice how these problems are numbers 1 and numbers 2. You have problem number 1 and number 4 on your homework tonight. And those are probably the easiest problems that are going to be on your homework tonight. So I'm hoping you watch this video, and I'm hoping you get those, because the homework gets a little trickier, gets a little bit harder later on, right? I'm not going to ignore all the hard problems that are out there in geometry. You don't want to, like, later in life get to the SATs or some of the more advanced stuff, like, why didn't I at least see this in high school? So we get to the harder stuff too. But anyways, hopefully you get this easier stuff here. If you get it the first time, it's fine, right? Thank you for watching the video. Hopefully you get it now. Email me if you have any questions. Come to office hours today if you're having trouble. I'll talk to you guys later. Bye.